Hi, this is Hari Krishna. Welcome back to the Probability and Statistic video tutorial. In this video, we discuss about chi-square test for goodness of fit. Now, chi-square test is used to test whether there is any significant difference between observed frequencies and expected frequencies. And the test statistic is given by chi-square equals to summation I equals to 1 to n OI minus EI whole square divided by EI with a degree of freedom V equals to n minus 1. Here OIs are observed frequencies, EIs are expected frequencies. Now chi-square distribution is used to test whether there is any significant difference between observed frequencies and expected frequencies. Now we have properties of chi-square distribution. Chi-square distribution curve is not symmetrical. That means it is not normal curve. It lies entirely in the first quadrant. It depends only on the degree of freedom. Here alpha denotes the area under chi-square distribution to the right. The mean of the distribution is V, that is degree of freedom, and the variance equals to 2 times of the degree of freedom. Now coming to the example problem. A sample analysis of examination result of 500 students was made. It was found that 220 were failed, 170 had secured third class, 90 were placed in second class, and 20 got first class. Do these figures commensurate with the general examination result, which is in the ratio of 4:3:2:1 for the various categories? Now we have to check whether there is any significant difference between observed values and expected values. Here we have observed values 220, 170, 90 and 20. We have to evaluate expected frequencies given that in the general examination result the ratio is 4:3:2:1. Now coming to the solution. Testing hypothesis. Null hypothesis is we take there is no significant difference between observed and expected frequencies. Alternative hypothesis, the complement of null hypothesis, we take there is a difference between observed and expected frequencies. Now the level of significance, assume alpha equals to 5%. Now test statistic is chi-square cal. To evaluate test statistic, we have to find expected frequencies. Now from the given data, we have different classes: fail, third, second and first. Given 220 failed, 170 got third class, 90 got second class, 20 got first class. These are the observed frequencies. Now we have to evaluate expected frequencies with this ratio 4:3:2:1. Now if you observe, the total pots 4 plus 3 plus 2 plus 1 is 10. So this represents the total number of students. So 10 pots value equals to 500 students. Now evaluating 4 pots value. If 10 pots value equals to 500, then 4 pots value equals to 4 divided by 10 into 500, that gives 200. So 200 students were failed in the general examination. Now evaluating 3 pots value. If 10 pots value is 500, then 3 pots value is 3 divided by 10 into 500, that equals to 150. So this is the number of students who got third class in the general examination. Similarly, evaluating the number of students who secured second class, that equals to 2 divided by 10 into 500, that equals 100, and evaluating the students who got first class, that indicates 1 divided by 10 into 500, that equals to 50. Now these are the observed frequencies OIs, these are the expected frequencies EIs. Now evaluating the squares of the differences OI minus EI, that gives 220 minus 200 whole square, that equals 400. 170 minus 150 whole square equals to 400. 90 minus 100 whole square equals 100. 20 minus 50 whole square equals to 900. Now evaluating the ratio OI minus EI whole square divided by EI, that is 400 divided by 200 equals 2. 400 divided by 150 equals 2.6. 100 divided by 100 equals to 1. 900 divided by 50 equals to 18. Now evaluating the sum of these values, that gives chi-square cal equals to summation I equals to 1 to n OI minus EI whole square divided by EI, that equals to 23.6. So this is the test statistic chi-square cal. Now for the level of significance alpha equals to 5% with the degree of freedom v equals to n minus 1, that equals 4 minus 1. Here n equals to 4. Here we have 4 different classes. So n equals to 4. 4 minus 1 equals to 3. From chi-square table, chi-square tab equals to 7.815. Now if you observe clearly, is the chi-square cal 23.6 is greater than chi-square tab. So conclusion is clearly chi-square cal is greater than chi-square tab. Therefore, the null hypothesis has to be rejected at the level of significance 5% and the alternative hypothesis has to be accepted. That means there is a significant difference between observed and expected frequencies. Now coming to the next problem. A pair of dice are thrown 360 times and the frequency each sum indicated below. Would you say that the dice are fair on the basis of chi-square test at 5% level of significance? Given sum 2, 3, 4 up to 12 and it frequencies 8, 24, 35 and so on 14. That means if the dice thrown 360 times, we get the sum 2 8 times, sum 3 24 times, sum 4 35 times and so on. These are the observed frequencies. Now we have to evaluate expected frequencies by classical definition of probability. Expected frequency of sum 2 is nothing but the probability of getting sum 2. Now we evaluate for single trial and then we apply for 360 trials. Now for one trial, evaluating the probability of getting sum 2, sum 3, sum 4 and so on, sum 12. Now observe this. Here the total possible outcomes n of s equals to 6 square, that equals to 36. Sample space is the collection of order pairs 1 1, 1 2, 1 3 and so on 1 6 and so on 6 1, 6 2, 6 3 and so on 6 6. So in this sample we have 36 elements or order pairs. So n of s equals to 36. Now evaluating the probability of getting sum is 2. Now the probability definition is P of x equals to n of e by n of s. Here n of e is the number of favorable outcomes, n of s is the total possible outcomes. Now if you observe here, e is the event that contains the order pair whose sum is 2. In this sample space we have only one order pair whose sum is 2. That is e equals to, we have only one order pair 1 comma 1 whose sum is 2. Therefore n of e equals to 1. The probability of getting sum 2 is P of x equals to n of e by n of s, that equals to 1 divided by total possible outcomes 36, 1 by 36. Now next, evaluating the probability of getting sum 3. Before that, now take the event e, the collection of all favorable outcomes. That is, we have to collect all the order pairs whose sum is 3. Now in the sample space we have 1 2 2 1. These are two possible or favorable outcomes. Since the sum of the digits is 3, we have only two order pairs 1, 2, 2, 1. So n of e equals to 2. Now the probability of getting sum 3 is p of x equals to n of e by n of s equals to 2 divided by 36. Next, evaluating the probability of getting sum 4 is n of e by n of s. Here e is the event, the collection of order pairs whose sum is 4. That is, E is the collection of order pairs whose element sum is 4. Now, if you observe, we have only 3 such elements 1, 3, 2, 2, 3, 1 whose sum is 4. So, n of E equals to, here we have 3 elements. So, n of E equals to 3, n of S equals to 36. Now, evaluating the each and every event probability like this. Next, evaluating the probability of getting sum 5, sum 6, sum 7. Here we represented in table form. The probability of getting sum 2 is 1 by 36, getting sum 3 2 by 36, getting sum 4 3 by 36, and so on. Now, expected frequencies. This is the probability of getting sum 2 for one trial. Here we have 360 trials. So for 360 trials, the probability is p of x into 360, that is 1 by 36 into 360, that gives 10. Similarly, for 360 trials, getting the sum 3 is 2 by 36 into 360, that gives 20. Getting sum 4, the probability is 3 by 36 into 360, that gives 30, and so on. We get 40, 50, 60, 50, 40, 30, 20, 10. So these are the expected frequencies. Here we evaluated probability of getting sum 2 is 1 by 36, sum 3 is 2 by 36 for single trial. Here we have 360 dice are thrown 360 times. So we have to evaluate for 360 trials is nothing but probability of one trial into 360 times. That gives 10, 20, 30, 40, and so on, 20, 10. Now the expected, these are the expected frequencies. Now observed frequencies already given in the problem 8, 24, 35, 37, and so on, 14. Now coming to the testing hypothesis. Null hypothesis always says that there is no significant difference between observed frequencies and expected frequencies. Alternative hypothesis is complement of null hypothesis. There is a difference between observed and expected results. Clearly given alpha equals to 5%, that is 0.05. Now evaluating the chi-square cal with the help of this table. Given sum 2, 3, 4 up to 12 and the observed frequencies given in the problem and expected frequencies, we evaluated the values 10, 20, 30, and so on, 10. Now finding the squares of the differences, OI minus EI whole square, that gives 8 minus 10 whole square, 4, 24 minus 20 whole square, 16, and so on. Now the ratio OI minus EI whole square divided by EI, that equals to 4 divided by 10, that equals 0.40, 16 divided by 20, 0.80, and so on. Now finding the sum of all these values, summation I equals to 1 to n OI minus EI whole square divided by EI equals to 7.45. This is nothing but the chi-square cal. Now coming to the tabulated value, at the given level of significance alpha equals to 5% with the degree of freedom V equals to n minus 1. Here the sample size is 11, so 11 minus 1 equals to 10. From chi-square table, we can observe that chi-square tab equals to 18.307. If you observe clearly, chi-square cal is 7.45 is less than chi-square tab. In the conclusion, clearly we can observe that chi-square cal is less than chi-square tab. In this situation, null hypothesis has to be accepted at the given level of significance. That is, there is no significant difference between observed and expected results. So these are the problems related to chi-square test for goodness of fit. We will continue in the next video.